So today we will continue with the graphing reciprocal functions. Two more to do. First is this one. So as we were talking last time, we have no vertical asymptote. And the reason is because we cannot make the denominator be 0. You could plug any number in here. If you plug in -2 and you square it, it becomes 4, so you'll never be able to get 0 on the bottom here. Horizontal asymptote, there is. So the degrees are the same here. The top is x squared and the bottom is x squared. So it's the coefficient of the top over the coefficient of the bottom, so -4/1. So y equals -4/1, or -4 is your horizontal asymptote. So now I'm gonna go ahead and draw the vertical asymptote. So it's right here at -4. -4. Now, that's all the information I have. So we're gonna go to a table of values, x, y. I think the first thing I'm gonna do is find if I have an y-intercept. So I make x 0, that becomes 0, 0, 0/4. So it gives me 0, so I know I have a point right here. How about if I try going this way and that way? So I'm gonna try -1 and 1. So -1 squared, I'm just gonna try the 1. 1 squared is 1 times -4 is -4. And that's 1 plus 4 is 5, because 1 squared is 1. So -4/5 is -0.8. And this one also will give you -1.8. Sorry, -0.8. That's what I mean, not 1.8. So just -0.8. The reason is when you square a negative number is going to be positive. So 1 and -1 will give you the same answer. I'm going to try also -2 and 2. So I'm going to put in the 2 there. That's 2 squared is 4 times -4 is -16. 2 squared is 4 plus 4 is 8. -16/8 is -2. So that gives me -2. The -2 also will give you -2, just because when you square a negative number here, it still give you a positive. So the same solution that you got from 2, you're gonna get from -2. So let's just plot those points. So we have -1 and 0.8, 1 and 0.8, approximate, you know, and then -2 and -2, and 2 and -2. So these are enough points because I have a horizontal asymptote. So I know this is gonna do this and get very close to the horizontal asymptote, and it's gonna do this, yeah. Same thing here, so, and then just level off right there, kind of thing. So that's the kind of graph you're gonna get for this one. This is finished. I'm gonna go to this one right here. Again, I'm just using table of values, but the x values that I use x values that make sense to me, because I wanna know the behavior as we go this way and that way, and knowing that I have a horizontal asymptote and all of that. But anyways, we're gonna go to this one right here. So this one, vertical asymptote. See this bottom here, I could factor out the 2 and I get x plus 1 if I do that. And right away, I see the x value that makes the bottom 0. It is x equals -1. So the vertical asymptote will be x equals -1. no horizontal asymptote. And the reason, as we said yesterday, that if the degree on top is greater than the degree on the bottom, then you have no horizontal asymptote. But also we said if the degree on top is greater than the degree on the bottom, then we will have oblique asymptote. And the oblique asymptote, to find out what it is, you have to do long division, divide the top by the bottom. So if I do long division, I'm dividing by 2x plus 2. And I have x squared minus x plus 4. So long division, basically, you do x squared divided by 2x, and that will give you half x. Half x times 2x is x squared, and half x times positive 2 will give you just x. Now I subtract x squared minus x squared is gone. Negative x minus positive x will give me negative 2x. Now I'm going to bring the 4 down, and I'm going to get plus 4. So therefore, I do the same thing again, divide the first thing from here by the first thing from the divisor, and I will get negative 1. And therefore, now I put negative 1 through here and put it underneath. So negative 1 times 2x is negative 2x. Negative 1 times positive 2 gives me negative 2. Sorry, negative 2. Now I subtract again. That will be gone, and the remainder is 6. Okay, that doesn't matter. Now this quotient right here, the quotient right here that I got from the long division, this is my oblique asymptote. And therefore, the oblique asymptote is basically y equals half x minus 1. So if I'm graphing the oblique asymptote, I have y-intercept of negative 1, and then the slope is 1/2, so I go up 1 over 2, up 1 over 2, or down 1 here over 2 this way. And therefore, this is how my oblique asymptote is gonna look like. So now also I'm gonna draw my vertical asymptote as well, which is through negative 1. Sorry, that doesn't look good. Let me just try to make it a little bit straight. Okay, so now we know what our asymptotes are. We know this asymptote is basically a guidance for me to see where the graph is getting close to. So from there, I have to do a table of values to figure out where everything is going. So x, y, and always, as I said to you, find few points on this side of the vertical asymptote and on this side of the vertical asymptote. So I'm gonna start off with 0, maybe 1, and then negative 1 and negative 2. And I'll see what kind of points they give me. And hopefully those will be enough to draw my graph. So if I put 0 there, I'm gonna get 2, because the x's will cancel, the 0 will cancel all the x's, and we end up with 4 divided by 2, which is 2. If I put n1, that's 1 minus 1, which is 0, plus 4, it's 4, and 2 times 1 is 2, plus 2 is 4, so I have 4 over 4, which gives me 1. So I'm just gonna go ahead and plot these 2 points. So I have this point right here at 2, and I have 1 and 1. That's what I got. I'm gonna plug in the -1 right here, so that will give me 1. Minus -1 is 2, plus 4 is 6. Over 2 times -1 is -2. I cannot use -1, sorry. That should be a -2 there. And that should be a -3. Because remember, -1 was a vertical asymptote. So if I plug it in, I'm going to get 0 on the bottom, and that doesn't work. So I'm going to plug in -2. That's 4. Plus 2 is 6. Plus 4 is 10. And if I put a -2 there, that's -4. Plus 2 is -2. 10 divided by -2 is -5. So I'm going to get -5 right here. And also put a -3. I'm going to get 9 plus, because minus -3 is going to be a +3. 9 plus 3 is 12. Plus 4 is 16. And if I put a -3 on the bottom, that's -6 plus 2 is -4. So 16 divided by -4 gives me -4. So I have a point at -2 and -5. And I have a point at -3 and -4. So just from knowing this 2 points here and 2 points there, I definitely know this is gonna get very close to the asymptote this way, and then it's gonna come and hit this point right here and do this, get very close to the asymptote that way. And the same thing here, you know, I get very close to the asymptote this way. Then if I go this way, I have to come to this point right here and then get very close to the asymptote that way. Just ignore that little portion right here. This eraser usually erases everything. Okay, got it, done it. And that's basically how you graph that kind of oblique asymptote. You have points and you have asymptotes that you know you're going to get very close to. You could always try to figure out what kind of points you get in here, how far it goes deep here, but you don't really need to. But you know, these 2 points have to meet somehow, and since you're going this way and you're going that way and getting closer to the asymptote, I would definitely, I'm just gonna do something here. I don't like the way this was drawn. So so this is doing this, and then kind of doing this, yeah. It's getting close to the asymptote, that's it. Yeah, and that's basically how you graph something with an oblique asymptotes. 2 points give you an idea of how roughly the graph is gonna look like. I hope you could understand this, and till next time, stay safe. Goodbye.